In chapter number 8, we're going to move our discussion into talking about the different types of waves. Now, when we go ahead and we talk about waves, a wave is just going to be any disturbance that's going to travel through matter or empty space. And what I mean by a disturbance is I'm talking about energy. I'm talking about a rock being dropped into water. I'm talking about sound waves. Those are all going to be things that are going to be disturbances that are able to travel through matter or empty space. Now, empty space, obviously, we understand what that is. But matter is also often going to be referred to as a medium. It is the material in which that wave is traveling. So as I'm talking to you now, I'm talking and my sound wave is traveling through air. If you take a rock, drop it in water, and you see the little ripples occurring on the water is going to be the medium. Honestly, if we put a train on a train track and all of a sudden you feel the vibrations on the ground or on the rail, that is going to be the medium. So the medium is the material in which that wave is traveling. Mechanical waves. A mechanical wave is going to be any wave that needs a material to transfer in. It needs to have that medium. Without the medium, it doesn't move. Okay, so the energy is moving in something like a solid, a liquid, or a gas. There are going to be two types of mechanical waves. The first one is going to be a compressional wave, and the second one is going to be a transverse wave. Now, for compressional waves, when we look at the medium is going to move back and forth to the direction in which that wave is moving. So we can say that they are going to be parallel to one another. I have a graphic on the next slide that's going to go ahead and talk a little bit or show you the different types of compressional and transverse waves. But this one, like I said, it moves back and forth, or it's moving in the same direction that that energy is moving. Now there's two parts on a compressional wave. This is the part where they are really close together. When you compress something, you squeeze it close together. So compressions on a compressional wave are the parts where the medium is really close together. And the rarefactions are the part of the medium where it's spread out. Okay, so close together, compressions, spread out are going to be your rarefactions. The other type of mechanical wave is going to be a transverse wave. A transverse wave is a wave that moves the medium at right angles. So we're going to say the wave moves up and down, or the medium moves up and down, but the wave appears to go left to right. So they are at right angles with one another. So when we go ahead and we go to this graphic, waiting for it to come up. Okay, so the first one, they call it a longitudinal wave. In our book, we're going to be calling it a compressional wave. But when you look at this, I mean, as I follow it, it looks like everything is moving all the way from the left side to the right side. But you can see this red dot here. And if you follow that red dot, it's going forward and it's going back. Now this picture down here, actually the arrows are showing you better. Okay, going forward and back. So this is moving parallel, and look at the wave. Here it goes from left to right. On a transverse wave, okay, here's this crest. This top part looks like it's going all the way along that top. But pick an individual particle, okay? That particle right there. All it seems to be doing is going up and down, but the wave itself appears to be moving left to right. So in a transverse wave, we've got the right angles. One's going up and down while the energy is moving left to right. You had your compressional wave where it's moving parallel, back and forth, while the wave appears to be moving left to right. So you can see here, parallel, back and forth, wave energy moving left to right. All right, the last type of wave. This is going to be an electromagnetic wave. And the thing that's special about electromagnetic waves are mechanical waves. We said they needed a material. They needed the solid. They needed the liquid. They needed the gas to travel in. Without them, they don't exist. Electromagnetic waves, they can travel through empty space. They don't need to have the solid, liquid, or gas. So some examples of electromagnetic waves. Sunlight. That's how we're getting our energy or heat from the sun. Radio waves, if you watch your favorite TV show, listen to your favorite radio station. Gamma rays, microwaves. Microwaves, I know we're used to it as in popping popcorn, but technically microwaves are like telecommunications. Those are going to be some of the like army satellites, military satellites that are in space that are transferring information also. If you've ever broken a bone, x-rays, technically x-rays, are going to be classified as electromagnetic waves. So today's discussion mainly was about what waves were. We had two types of mechanical waves, the ones that need a material, need a medium. Those are compressional waves and transverse waves. And then the other type of waves, these are just energy. Okay? Electromagnetic waves is the other type of energy.